This lesson will take us through the solutions to the revision questions that were set in Friday's lesson. So starting with the first question that is asking us to simplify an algebraic expression, we're being asked here to expand 3x squared into the set of brackets, which means we need to multiply every term inside that brackets by 3x squared. So in doing so, 3x squared times 4 gives me 12x squared, and 3x squared times negative 2x gives me negative 6x cubed, and the plus 5x squared on the end that is outside of that brackets is not included in the expansion, but it is a part of the original question, and so we need to leave it as a part of our answer. At this point, we can now go and collect our like terms. So we can see that we have two terms that involve an x squared, a 12x squared, and a 5x squared, and the addition of those would give us 17x squared. But the negative 3x cubed in the middle doesn't have any other like terms to add to it, and so it stays as it is. And our final expression gives us 17x squared minus 6x cubed. Now let's move on to question 2, which was asking us to calculate the area of two different shapes. The first one being a composite shape made up of a semicircle and then a triangle. If we consider the semicircle first and we call it area 1, we know that the area of a regular circle is given by the formula pi times the radius squared, where in our case the radius would be half of the 13 shown, with the 13 being the diameter. But we only have half of the circle here, which means we need to halve our area formula. So in substituting all of this information, the area of that semicircle would be found by doing a half times pi times our radius length, which we have worked out to be 7.5 centimetres. And we need to square that radius length as shown in our formula, giving us an approximate area for area 1 of 88.36 square centimetres, rounded to 2 decimal places. Now considering area 2, which is our triangular area, we know that the area of a triangle is given by the formula half times the base length, which we can see is 13, times the height of the triangle, which we can see is 12. There's no manipulation needed of either of our dimensions, and so if we substitute the given information into our formula, we would have a half times 13 times 12 centimetres, giving us a total area for area 2 of 78 square centimetres. Now to calculate the total area of our composite shape, we need to add together area 1 and area 2, as these are the two areas that have been combined to make our overall shape. So adding 88.36 to 78, we get a total area for our composite shape of 166.36 square centimetres. If we now look at the composite shape that was given in part B, this shape's been formed by cutting a square out of the middle of a triangle. There is a lot of information given for this question, which means that there are a couple of methods that we could use to get the total shaded area that we're required to find. We could, for instance, just work out the dimensions of each of these 3 triangles shown, calculate their areas separately, and then add them together. But I think that would probably be a longer method than the one I'm about to show you. As we can clearly see, this square in the centre here has all sides equaling 6 centimetres, and it has been cut out of the shape, meaning that if we find its area, we can subtract it from the entire triangle sitting on the outside. If we call the square area 1, and knowing that the formula for the area of a square is just to square the side length given, and the side length given is 6, the area of that square is equal to 36 square centimetres. Now considering the triangle on the outside, we can see that its total base length is very clearly given as 10 centimetres. But considering all the heights given in this shape, we can see that the height of that square is consistently 6 centimetres throughout that whole shape. And we are given the additional height to the apex of our triangle here as 2 centimetres, meaning that the total height of our triangle is actually given to us in parts in this question and is equal to 8 centimetres. So I can very easily calculate area 2, that being the area of the triangle on the outside, as a half times the base length, which we said was 10 centimetres, times the height, which we just worked out was 8 centimetres, giving us a total of 40 square centimetres. This time, the area of the shaded section is found by taking the area of the triangle, or area 2, and subtracting from it the area of the square, or area 1, giving us 40 square centimetres minus 36 square centimetres, and a total shaded area of 4 square centimetres.